Hello everyone, welcome to Aakruthi Mathematics Simple Mathematics Classes. This is Differentiation Class 10. I am Theorem K. In this class, I am going to discuss about Rolle's Theorem and Mean Value Theorem. First we see definition of Rolle's Theorem. So consider a function f from closed interval a b to r, continuous on closed interval a b and differentiable in open interval a b. So this is first two conditions. So function should be continuous on closed interval a b and function should be differentiable in open interval a b. So such that f of a equal to f of b. So this is third condition for Rolle's theorem. So first function should be continuous and it should be differentiable and f of a equal to f of b. So where a and b are some real numbers. So here f of a equal to f of b, for a and b are some real numbers. If these three conditions are satisfied, then there exists some c belongs to AB such that f dash c equal to 0. So c belongs to open interval AB such that f dash c equal to 0. So if function is continuous in closed interval AB and differentiable in open interval AB and f of a equal to f of b, then there exists some c in open interval AB such that f dash c equal to 0. So this is statement of Rolle's theorem. We see the diagrammatic representation of Rolle's theorem. So consider a function which is continuous in closed interval AB, which is differentiable in open interval AB. Now here it is f of a and f of b are same. So f of a and f of b are same. That is value of function at a and b are same. Then there exists one c in between a and b such that f dash c equal to 0. So f dash c equal to 0 means slope of the tangent at c equal to 0. So that is tangent is parallel to x-axis. There is one c in between a and c such that f dash c equal to 0. That is slope of the tangent is 0 implies tangent should be parallel to x-axis. There is one point c comma f of c where tangent is parallel to x-axis. So that is f dash c equal to 0 implies tangent is parallel to x-axis. So next we see some problems. So these problems are from exercise 5.8. Now first problem, verify Rolle's theorem for the function y equal to x square plus 2 when x belongs to minus 2 to 2. Now first, given function is a polynomial function. So given function is y equal to x square plus 2. It is a polynomial function, hence it is continuous. Every polynomial function is continuous. Hence given function y equal to x square plus 2. It is also continuous in closed interval minus 2 to 2 and differentiable at open interval minus 2 to 2. So polynomial function is continuous and differentiable at open interval minus 2 to 2. So next we find function value at x equal to minus 2. So we take x equal to minus 2. So that is f of minus 2 is minus 2 square plus 2. Minus 2 square is 4. 4 plus 2 is 6. So therefore f of minus 2 is 6. So next we find f of 2. So f of 2 is 2 square plus 2. That is 2 square is 4. 4 plus 2 is 6. Now here f of minus 2 and f of 2 are same. So therefore all the three conditions for Rolle's theorem is satisfied. So function is continuous, function is differentiable and f of a equal to f of b. Now here f of minus 2 is f of 2. All three conditions for Rolle's theorem are satisfied. So now we differentiate given function. So f of x is x square plus 2. So therefore f dash x is 2x. So by Rolle's theorem, we can find one c such that f dash c equal to 0. Now f of x is 2x. So therefore f dash c equal to 2c. So therefore 2c equal to 0. When we simplify this, we get c equal to 0. And 0 belongs to minus 2 to 2. So therefore Rolle's theorem verified. So c value is 0 and 0 belongs to open interval minus 2 to 2. Hence Rolle's theorem is verified. So next problem, verify Rolle's theorem for the function y equal to x square plus 2x minus 8 when x belongs to minus 4 to 2. Now here also given function is a polynomial function, that is y equal to x square plus 2x minus 8 is a polynomial function, hence it is continuous in closed interval minus 4 to 2 and differentiable in open interval minus 4 to 2. So function is continuous and differentiable. So now we find f of minus 4. So f of minus 4 is minus 4 square plus 2 into minus 4 minus 8. So minus 4 square is 16 and here 2 into minus 4 is minus 8. Again it is minus 8. It is 16. Minus 8 is 0. So therefore f of minus 4 is 0. So next we find f of 2. Now f of 2 is 2 square plus 2 into 2 minus 8. Now 2 square is 4. 4 plus 4 is 8. 8 minus 8 is 0. So f of 2 is also 0. Now here f of minus 4 and f of 2 are same. So therefore all three conditions for Rolle's theorem satisfied. So function is continuous, function is differentiable and f of a equal to f of b, that is f of minus 4 equal to f of 2. So all three conditions for Rolle's theorem satisfied. So next we find f dash x. So differentiate given function, x square differentiation is 2x and 2x differentiation is 2. So f dash x is 2x plus 2. So by Rolle's theorem we can find c such that f dash c equal to 0. So that is 2c plus 2 equal to 0. we solve for c, we get 2c equal to minus 2 and c equal to minus 2 by 2, that is c equal to minus 1, and minus 1 belongs to open interval minus 4 to 2. So c equal to minus 1, it belongs to open interval minus 4 to 2. So therefore Rolle's theorem is verified. So c value is minus 1 and minus 1, it is within open interval minus 4 to 2, hence Rolle's theorem is verified. So next question, examine whether Rolle's theorem is applicable for the function f of x is greatest integer function of x when x belongs to 5 to 9. So here f of x is greatest integer function of x. Now here given function is greatest integer function and which is not continuous in 5 to 9. So given function is greatest integer function and it is not continuous in 5 to 9. So hence Rolle's theorem is not applicable for f of x equal to greatest integer function of x. Since condition of Rolle's theorem is not satisfied, so Rolle's theorem is not applicable for given function f of x is greatest integer function of x. So Rolle's theorem is not applicable for given function. So next problem, examine whether Rolle's theorem is applicable for the function f of x is x square minus 1 when x belongs to 1 to 2. Now here f of x is x square minus 1. Now given function is a polynomial function, hence it is continuous in closed interval 1 to 2 and differentiable at open interval 1 to 2. So given function is polynomial function, hence it is continuous and differentiable. Now we find f of 1. Now f of 1 is 1 square minus 1, it is 0. And f of 2 is 2 square minus 1 and 2 square is 4, 4 minus 1 is 3. Now here f of 1 is 0 and f of 2 is 3, and here f of 1 is not equal to f of 2, that is f of a is not equal to f of b. So therefore condition for Rolle's theorem is not satisfied. So therefore Rolle's theorem is not applicable for given function f of x equal to x square minus 1. So Rolle's theorem is not applicable for the function f of x equal to x square minus 1 since f of 1 is not equal to f of 2. So next problem, if f from closed interval minus 5 to 5 to r is differentiable function and f dash x does not vanish anywhere, so then prove that f of minus 5 is not equal to f of 5. Now here it is given that function is differentiable function and f dash x does not vanish, that is f dash x is not 0 for any value. So we have to prove that f of minus 5 is not equal to f of 5. Now given function is differentiable function, hence it is continuous. We know that every differentiable function should be continuous function. So given function is differentiable, hence it is continuous also. Now here f dash x is not equal to 0. So therefore f dash c is not equal to 0 for any value of c. So f dash c is not equal to 0 for any value of c. So now here first two conditions of Rolle's theorem are satisfied. A function is continuous and function is differentiable. If all conditions of Rolle's theorem are satisfied, then f dash c should be 0. So since f dash c is not equal to 0, all the conditions of Rolle's theorem are not satisfied. That is f of minus 5 should not be equal to f of 5. So since Rolle's theorem is not satisfied here, f of 5 is not equal to f of minus 5. Now here f dash c is not equal to 0, that implies Rolle's theorem is not satisfied. Therefore conditions of Rolle's theorem is not satisfied. So condition of Rolle's theorem is f of a equal to f of b is not satisfied, then only we get f dash c not equal to 0. So since f dash c not equal to 0, f of a should not be equal to f of b. So therefore f of minus 5 is not equal to f of 5. So next we see mean value theorem. So first we see definition. Let f be a function from closed interval ab to r, continuous on closed interval ab and differentiable in open interval ab. So given function is continuous in closed interval ab and differentiable in open interval ab. So then there exists some c in open interval ab such that f dash c equal to f of b minus f of a divided by b minus a. So if given function is continuous and differentiable, then there exists one c in open interval ab such that f dash c equal to f of b minus f of a divided by b minus a. Now we see diagrammatic representation of this theorem. So you consider a function which is continuous in closed interval ab and differentiable in open interval ab. Now here we have f of a and f of b. When x equal to a, we get y equal to f of a. When x equal to b, we get y equal to f of b. Now here we can find one value of c in between a and b such that f dash c equal to f of b minus f of a divided by b minus a. So that is f dash c equal to f of b minus f of a divided by b minus a. Now we studied slope of a tangent. Slope of a tangent is given by y2 minus y1 divided by x2 minus x1. Now here f of b is y2 value, f of a is y1 value, and b minus a is x2 minus x1. Mean value theorem gives the slope of the tangent. So therefore f dash c equal to f of b minus f of a divided by b minus a. So it is y2 minus y1 divided by x2 minus x1. And here we can write f dash c equal to f of b minus f of a divided by b minus a. So therefore f dash c represents slope of the tangent at c comma f of c. So next we discuss some problems. These problems are from exercise 5.8. Now first problem, verify mean value theorem for the function f of x is x square minus 4x minus 3 in closed interval 1 to 4. Now here given function is a polynomial function, hence it is continuous in closed interval 1 to 4 and it is differentiable in open interval 1 to 4. So polynomial function is continuous and it is differentiable. So next we find f of 1. Now here a value is 1, so we find f of 1. F of 1 is 1 square minus 4 into 1 minus 3. And 1 square is 1 and minus 4 into 1 is minus 4 and it is minus 3. So it is 1 minus 4 minus 3 is minus 6. So f of 1 is minus 6. So next we find f of 4. So here b value is 4. So we find f of 4. So it is 4 square minus 4 into 4 minus 3. So 4 square is 16 and again it is minus 16. 16 cancel, remaining is minus 3. So therefore f of 4 is minus 3. In mean value theorem, f of a and f of b may not be equal. So here f of 1 is minus 6 and f of b is minus 3. They are not equal. So here we can apply mean value theorem. Now first we differentiate given function. Now f of x is x square minus 4x minus 3. When we differentiate that we get f dash x. So differentiation of x square is 2x and differentiation of 4x is 4. So therefore f dash x is 2x minus 4. Now by mean value theorem we have f dash c equal to f of b minus f of a divided by b minus a. Now here we have f dash x is 2x minus 4. So therefore f dash c is 2c minus 4. In place of x you substitute c. So therefore f dash c is 2c minus 4. So therefore 2c minus 4 is f of b. So f of b is minus 3 and f of a. So f of a is minus 6. So we get f of b minus 3 minus f of a, it is minus 6 divided by b minus a, that is 4 minus 1. So we get 2c minus 4 equal to minus 3 minus of minus 6 divided by 4 minus 1. When we simplify, we get 2c minus 4 is minus 1, that is minus 3 minus of minus is plus 6. Minus 3 plus 6 is plus 3 divided by 4 minus 1 is 3. 3 divided by 3 is 1. So we get 2c minus 4 equal to 1. Taking 4 to other side, we get 2c equal to 5. And when we simplify, we get c equal to 5 by 2. And 5 by 2 belongs to open interval 1 to 4. So c value is 5 by 2, that is 2.5. 2.5 belongs to open interval 1, 4. So hence mean value theorem verified. So here c value is 5 by 2 and it belongs to open interval 1, 4. Hence mean value theorem verified. So next problem, verify mean value theorem for the function f of x is x cube minus 5x square minus 3x when x belongs to closed interval 1 to 3. Now here f of x is x cube minus 5x square minus 3x and x belongs to closed interval 1 to 3. Now here also given function is a polynomial function, hence it is continuous at closed interval 1 to 3 and differentiable in open interval 1 to 3. Given function is continuous and differentiable. So now we find f of 1. F of 1 is 1 cube minus 5 into 1 square minus 3 into 1. So it is 1 minus 5 minus 3. So answer is minus 7. So it is 1 minus 5 is minus 4. Minus 4 minus 3 is minus 7. So next we find f of 3. So f of 3 is 3 cube minus 5 into 3 square minus 3 into 3. So it is 3 cube is 27 minus 5 into 3 square is 9. 9 5 is 45. It is 27 minus 45 minus 9. So answer is minus 27. So f of 3 is minus 27. Now here f of a is minus 7 and f of b is minus 27. So now f dash x, that is differentiate the given function. F dash x is x cube differentiation is 3x square. And 5 is constant, x square differentiation is 2x, 2 into 5 is 10, so we get 5x square differentiation is 10x and 3x differentiation is 3, so we get minus 3, so therefore f dash x is 3x square minus 10x minus 3. So now by mean value theorem we have f dash c equal to f of b minus f of a divided by b minus a. Now f of x is 3x square minus 10x minus 3, so therefore f dash c is 3c square minus 10c minus 3 and f of b is minus 27 minus f of a is minus 7, we get minus 27 minus of minus 7 divided by 3 minus 1. So here b value is 3, a value is 1. So we get 3 minus 1. Now minus 27 minus of minus is plus 7. Minus 27 plus 7 is minus 20. Minus 20 by 2 is minus 10. So we get 3c square minus 10c minus 3 equal to minus 10. And taking minus 10 to this side, we get 3c square minus 10c minus 3 plus 10 is plus 7. So it is 3c square minus 10c plus 7 equal to 0. And it is quadratic equation. We split the middle term. We can write minus 10c as minus 3c minus 7c. And here 3c is common. We can take 3c outside. And here 7 is common. After taking common, we can factorize. We get 3c minus 7 into c minus 1 equal to 0. Now here we take 3c common outside, remaining is c minus 1. And here we take minus 7 common outside, remaining is c minus 1. So we get c minus 1 into 3c minus 7 equal to 0. So this implies 3c minus 7 equal to 0 or c minus 1 equal to 0. So therefore c equal to 7 by 3 or c equal to 1. So C equal to 1 or C equal to 7 by 3. But 1 does not belong to open interval 1 to 3. So in open interval 1 and 3 does not belong to this interval. So therefore 1 does not belong to open interval 1 comma 3. So therefore C value should be 7 by 3 only. So C value 1 is not possible. So C value is 7 by 3. And 7 by 3 belongs to open interval 1 comma 3. Hence mean value theorem is verified. So here C value is 7 by 3. It belongs to open interval 1 comma 3. Hence mean value theorem is verified. So that's all in this video. Differentiation chapter explanation is completed. Watch other chapter videos in my YouTube channel. Thank you for watching. Please like, share and subscribe the channel for more video notification. Subscribe my YouTube channel Aakruthi Mathematics Classes. Thank you once again.